Hello class, welcome to the first lesson of the biomechanics unit, levers. And levers are pretty interesting because depending on how we arrange the components of the lever, it affects the amount of effort that it takes to move the resistance. So during this lesson we'll look at the different types of levers that are involved in movement. Before we talk about levers, let's look at what is biomechanics. Biomechanics is a study of human movement from the perspective of the science of the internal and external forces acting on the body, and also the effects produced by these forces. So an example of internal force that could act on the body would be muscular contraction, which helps us move, and external force acting on the body could be gravity, which affects how we can move. So the importance of biomechanics is looking at what are the most efficient ways for movement and to improve our performance. What is the lever? In about 260 BC, an ancient Greek mathematician, Archimedes, stated, "Give me a lever long enough and a place to stand, and I will move the earth." So levers throughout the years have been used as tools to make movement or creating force a little bit easier. When we look at a lever, there has to be three parts. An axis, which sometimes is also called a fulcrum or a pivot point, a resistance, sometimes it's called a weight or a load, and then a force, sometimes called the effort. So these three things together create our lever. Now in our body, like we said, we can use levers inside and outside the body. In our body, the muscles and bones work as levers. Usually your axis or fulcrum is going to be your joint. The force creators are usually the muscles in our body, and the resistance is whatever force we're trying to move. First class levers have the fulcrum of the axis in the middle of the lever with the resistance of the load on one side and the force of the effort on the other side. An easy example of a first class lever is a seesaw. As you know, when you go on a seesaw, you're working back and forth with forces with the other person pivoting on the fulcrum. So there's a couple tools that are first class levers. A hammer, when you're pulling on a nail, you have the effort on the top of the handle, you're pivoting on the top of the hammer to pull out the resistance, which is the nail. Scissors, when you use scissors, the handle would be the effort, the fulcrum would be the screw that's holding the scissors together, and the load would be what you're applying the cut to. In the body, there's not that many first class levers. One example is on our skull. Our skull pivots on top of our spine. There's a pivot joint. So if I move my head up and down, there's some effort and resistance with the pivot point in the middle. The second class lever has the fulcrum axis at the end of the lever, the load or the resistance in the middle, and the effort or the force at the end of the axis. A classic example of a second class lever is a wheelbarrow, which again makes it easier to lift heavier loads. A couple examples you see on there for tools, we have a bottle opener, again the fulcrum's at the end, and nutcracker also with the fulcrum at the end. A movement example in our body would be a calf raise. So the toe joints would be our fulcrum, the foot would be the resistance, and the force would be created by our calf muscles when they contract. A third class lever has the fulcrum again at the end, the fulcrum axis, but this time the effort's in the middle and the load or resistance is at the end. If in our bodies, if we do a bicep curl, okay, we have the elbow joint would be the fulcrum, the bicep muscle would be the effort, and the load would be whatever we're trying to curl. So the dumbbell in that case would be the load. So most of our movements in our body are third class levers. You see on there a couple tools. Again, they're third class levers, tweezers, fulcrum one end, the load on the other end, and staple remover, same thing. We have the fulcrum, the effort in the middle, and the load at the end. A sport example of a third class lever would be Baseball or softball, where you're swinging a bat. Again, the fulcrum, the pivot points at the end. Our hands or efforts in the middle, and the resistance at the end of the bat when we're hitting the ball would make it a third class lever. When we calculate the force applied to levers, we look at torque. And torque is the application of a force perpendicular at a perpendicular distance to a joint or point of rotation. So three factors when we look at torque is the length of the force arm. You can see on the picture position B is using less force than position A because they're farther along the force arm. So the length of the force arm, the force applied, and the angle between the force vector and the lever arm. And that's actually measured using the sine function. So we can see that, again, on the wrench, it's better to be farther out on the handle so to generate more force or more torque. To summarize today's lesson, we looked at biomechanics. Biomechanics is when we look at human movement through the science that examines the internal and external forces acting on the human body and the effects produced by these forces. Biomechanics is important because whether we're looking at it individually as an athlete or as a coach, or if we have a group that's analyzed biomechanics, we can try to improve our performance. There's three types of levers we talked about today. A first-class lever has the fulcrum in the middle between the force and the resistance. A second-class lever has the resistance in the middle between the axis or fulcrum and the force. And the third-class lever has the effort in the middle between the fulcrum or axis and the resistance. Most of the movements in our human body are third-class levers. Torque is looking at the force that's created when we use the levers, the perpendicular force. And again, that force is dependent on the length of the arm of the lever, the force that's applied, and then also the angle of the perpendicular force. So some examples of levers: first class lever, we have the scissors; second class lever, we have the wheelbarrow; and third class lever when you're contracting your upper arm. So think about in your activities, what are some different movements and what might be the levers when you look at those different types of movements.